is the converse of the Pythagorean theorem. Now, the Pythagorean theorem was used to find a side length. The converse is used for something else that is completely different. The converse is used to classify triangles. In math, classify is a fancy way of saying naming. So we're going to determine if we have an acute triangle, an obtuse triangle, or a right triangle. Remember that C has to be your longest side. Now, the nice thing is the converse is very logical. If C squared is less than A squared plus B squared, then you have an acute triangle. Less than, small, acute, the smallest kind of angle, goes together. If C squared is greater than A squared plus B squared, you have an obtuse triangle. Greater than, bigger, the biggest angles, obtuse angles. And if C squared equals A squared plus B squared, we have a right triangle. Now, this next piece of information is important. It's actually taught earlier in geometry, and so we tend to forget about it when we go to talk about classifying triangles. But the triangle inequality theorem. States that the sum of the two smaller sides must be greater than the longer side. So, C compared to A plus B, C must be smaller, A plus B must be bigger. You can write it the other way. A plus B is greater than C. Either way works, but C has to be larger. So let's look at some problems here. First, determine if the three side lengths form a triangle. So I suggest that you circle the longest side because they're not always in order from least to greatest. The two smaller sides, 7 plus 3, have to be greater than the longest. 10 is bigger than 9, so yes to forming a triangle. Step 1. Step 2 is to classify as acute, obtuse, or right. We can't classify if we don't have a triangle. So I'm going to compare C squared to A squared plus B squared. All right, it doesn't matter which one I call A and B, so I'm going to say 7 squared plus 3 squared, but C has to be the 9 because that's the biggest. 81, 49 plus 9, 81 compared to 58. Well, 81 is definitely greater than 58. So in this case, I have an obtuse triangle. You can spell out the word triangle. I'm pretty lazy about that. I usually just use the symbol. So now I'd like you to pause the video and try number 2, please. Circle your largest. 21 plus 20 has to be greater than 29. 41 is greater than 29, so yes, we have a triangle. Now we're going to do C squared and compare that to A squared plus B squared. My value for C is 29. 21 plus 20. Okay, and I don't know 21 or 29. So 29 squared on my calculator, 841. 21 squared on my calculator, 441. I know 20 squared is 400. 841 compared to 841, this is equal. That means I have a right triangle. All right, I'd like you to pause your video and try number 3. Let's see, circle my longest side. 15 plus 8 is not bigger than 23. It's equal. So this one, not a triangle. Can't do anything else with it. Please pause your video and try number 4. Circle your longest side. 17 plus 17 is going to have to be bigger than 22. 34 is bigger than 22. So yes, we have a triangle. Now we're going to compare c squared to a squared plus b squared. C squared is 22. A is 17. B is 17. Okay, 22 squared is 484. Had to do that one on my calculator. 17 squared, though, I know is 289. So 484, and let's do 289 times 2. That's 578. When I compare that, c squared is less than. Less than means I have an acute triangle. All right, summary. The converse of the Pythagorean theorem allows us to classify triangles. And I'm going to say c squared greater than a squared plus b squared. I have an obtuse triangle. C squared less than a squared plus b squared. I have an acute triangle. And c squared equal to a squared plus b squared. I have a right triangle. Don't forget put a star by it. A plus B has to be greater than C or no triangle at all. All right, as time goes on, you're going to have to write your own summaries. Next up, special right triangles.